Hello, Mr. Bush here with a awesome new set of video notes over Newton's laws of motion. The first law we're going to talk about is the law of inertia, often known as the first law of motion. And the law of inertia states that an object at rest will stay at rest until acted on by an outside force, or an object in motion will stay in motion until acted on by an outside force. And this is kind of common sense. Objects don't move unless someone's putting a force on it. And once that object starts moving, you have to have a force to stop it. Typically that's going to be gravity or air resistance. But if you think about it, things don't move without a force causing them to move. Alright, let's go ahead and look at a few examples here. Okay, so in this example, we have a car crashing into a pillar going about 60 miles per hour. Timmy is going to continue to go at 60 miles per hour until some force stops him. Seeing how he didn't have a seatbelt on, he's just basically going to continue flying out here until either gravity or air resistance brings him to a complete stop. This is basically an example of Newton's law of inertia. It's stating that this object will continue in motion, this object happened to be Timmy, will continue moving until some sort of force stops it. Alright, we're going to take a look at one more example and then move on to Newton's second law. Okay, so in this example of the law of inertia, we have Billy Bob here, and despite his name, he is actually doing something significantly more intelligent than Timmy. He's wearing his seatbelt. So whenever his car comes to a very rapid stop, his body wants to keep moving, basically wants to keep in motion. However, it is stopped by the outside force of the seatbelt. So whenever you're moving and you come to a rapid stop, the mass of an object will basically have a tendency to keep it moving, and that effect is called inertia. Now, whenever I mention the mass, basically the more mass an object has, the more likely it wants to stay in motion, or the harder it is to stop it. And the less mass it has, the easier it is to stop it. And that kind of bridges or brings us into Newton's second law, or the law of the law of force and acceleration. Alright, the law of force and acceleration is very simple. Basically, the force on an object is going to be equal to the mass of that object multiplied by the acceleration on the object. And that's kind of common sense. A heavier object moving at the same speed as a lighter object will have more force. Kind of like if you dropped a bowling ball on your toe versus dropping a ping pong ball. The bowling ball will obviously hit with more force. So, what this equation states, and I always think the formula is a little bit easier than the written out law, is basically the force is going to be equal to whatever the mass is multiplied by whatever the acceleration is. So I'm going to go ahead and give you all a few examples real quick. Alright, in this example we basically have the same amount of force being applied to a heavy bowling ball and a very light soccer ball. As you can see, since the force is the same and the mass is much heavier on our bowling ball, its acceleration has to be a lot lower. And the mass is very low for the soccer ball, so since it was the same amount of force, its acceleration is going to be very high. Basically, given the same amount of force, heavier objects or more massive objects accelerate much slower than lighter objects. So if you give that bowling ball and the soccer ball the same amount of push, the bowling ball is going to accelerate much slower than the soccer ball. Alright, and we're going to have to continue the last law on a separate video. I appreciate y'all basically being patient with me, seeing how this is my first video. I know it was a little bit choppy. Thank you, and hopefully it helps.